Hello class, this is Mr. Diaz. Today we're going to go ahead and cover section 5.1. It is imperative that you do chapter 4, especially the last two sections, because it is related to this material. So if you haven't done the last two sections of chapter 4, I would advise you to do that first before you start tackling this section. Well, section 5.1 all has to do with the greatest common factor. Beforehand, we had seen the greatest common factor being used when it comes down to fractions. Basically, it was the largest number between the numerator and the denominator, and we reduced it. Well, here we're going to use another version of the greatest common factor, and it's going to be dealing with polynomials themselves. So if you haven't printed out, we are going to go ahead and take problems from section 5.1. Pretty much the first part is definitional, so we're not going to work from there. We're going to work from part 2 and number 3 right there. Those two sections right there. So let's take a look at this particular section. And I'm going to define the GCF as being a couple of different things. For example, a GCF could be a coefficient or coefficients, depending on what you have here. So if we take a look here, we have the two terms. We have 4x plus 12. So both of these have in common, you're going to have to take a look and figure out the greatest common factor between them. In other words, the largest number that is divisible into the coefficients, into 4 and into 12. Now there are a number of different multiples that we can use. Yes, you could use 2, but remember that is not the greatest number that could go into both 4 and 12. In this particular case, the GCF will be 4. So what you're doing here is the opposite of what we did in chapter 4. In other words, distribution, multiplying polynomials. So once you get your GCF, once you have identified it, and here we identified the GCF as being 4, then we're going to go ahead and factor it. That's what we call the actual extraction of that GCF. So here we're going to factor out the 4 from both the 4x and the plus 12. And simply enough, all you have to do is really just divide them. So 4 goes into 4x once, so it'll be 1x, or just simply x. You don't have to put the 1 in front of it. And 4 goes into 12 3 times. Essentially what you're doing is you're dividing. So if we take a look, this will be the answer for this particular one. So all we did here was just factor out a coefficient. And the coefficient, the greatest common factor of them, was the 4. Now if you want to verify whether this is correct or not, all you really have to do is just redistribute the 4. 4 times x will give you 4x. 4 times 3 will give you the 12. And it's that simple. Now keep in mind that you're going to have several greatest common factors, so just don't think it's just coefficient. Sometimes you're going to have variables. Now with the variables, it's a little bit different. So let's take a look at this example. With the variables, what we're dealing with is that you have to have the same variable or variables, because it could be more than one, and the smallest power. So in this particular example here, we have the coefficients. First, you take a look at your coefficients. 3 and 2, they don't share anything in common, so there's no GCF for the 3 and the 2. But we do see that both terms have the x in common. So both of them have the x in common, so that's what we're going to factor out. In this case, we're going to go ahead and factor out the smallest of the power. In this case, the smallest power is x squared. So once again, we're extracting that GCF. In this case, our GCF will be, and let's just jot it down here, the x squared. So we're going to factor out an x squared from 3x to the 5th, and we're also going to factor it out from 2x squared. So let's take a look. If we're going to factor it out, it doesn't work the same way as what we did with coefficients. When you factor out a variable, you're actually taking it away. So here we're taking away x squared from x to the 5th. So we're going to end up with 3x to the 3rd. In other words, you're taking out that x squared from x to the 5th, and you're left with x to the 3rd. And we're also going to factor it out from 2x squared. So if you're taking it out from there, we're left with plus 2. Once again, keep in mind that the greatest common factor for a coefficient and the greatest common factor for a variable are not the same thing. They share similarities, but they're not the same thing. So in this case, that will be your answer. Once again, if you want to verify your answer, redistribute the x squared. So x squared times 3x to the 3rd. Remember, there's a 1 in front of x squared, so 1 times 3 is 3. X squared times x to the 3rd. Remember, we use the product exponent rule, so we actually add the exponents. So that's going to give us 3x to the 5th. And 1x squared times 2 will give us, once again, 2x squared. So far we've seen two of them. We've seen the coefficient, we've seen the variable, but what if we have both of them? So that's what you're going to do. In this particular case, we're going to go ahead and factor out both the coefficient and the variable. So two different things. So let's remind ourselves. In this case, the 9 and the 24. So let's jot down this thing. The GCF for the numbers, or the coefficients here, 9 and 24, the largest number that is divisible into them is the number 3. So for sure we're going to factor out a 3 from those two terms. But if we take a look, they also have the variables in common. Once again, we're going to factor out the smallest power. In this particular case, we're going to, since both of them have y in common, we're going to factor out the y squared. Now remember, when you're factoring this out, what you're doing with a number, you're dividing. What you're doing with a variable, you're subtracting it away. So let's first start off with the first term, 9y to the 4th. So we divide 9 by 3. So that'll give us 3. And we're going to factor out y squared from y to the 4th. Remember, we're taking it away. So that'll give us y squared. We're going to repeat the process with the next one. 24 divided by 3, that'll give us 8. And we factor out the y squared. Since it's the same thing, there's not going to be a y left. And that would be our answer for this one. 3y squared parentheses 3y squared plus 8. Once again, if you want to verify your answer, all you simply have to do is just multiply them. 3 times 3, that's 9. Y to the 2nd times y to the 2nd, that is y to the 4th. Same thing for the next term. 3 times 8 is 24. And we tag along the y squared since this one doesn't have y. Alright, so far we've got the coefficient. So sometimes you're going to just factor out a coefficient, sometimes a variable, or sometimes a combination of those two. The last example that we have for this particular one is the polynomial. So yes, you could have a GCF as a polynomial. So if we take a look at it right here, notice that it looks a little bit stranger than the other ones, but it's a little bit more obvious. So we don't have a number in common, we don't have a variable in common, or a combination of this. But in this particular case, the greatest common factor, remember, what they share in common is the polynomial 5y minus 2. In other words, these two terms have the 5y minus 2 in common. And this will probably be the easiest type of factoring. So once again, this is what we're going to factor out. We're going to factor out the 5y minus 2 from both of them. So we factor it out from the first term, or essentially this part right here. In other words, we're taking it away. So we're left with x. And we're going to do it with the second term right here. So we factor out 5y minus 2, we're left with minus 3. And that would be your answer right there. So once again, this concludes the different types of GCFs that you're going to cover in this section. In our next part, we're going to go ahead and do some practice problems.